the research. But I guess the intent of them is to do some discussions with the interested parties and the industry, engage with the industry to understand, to make sure they are covering the right topics in their research. So the more the merrier. I think that workshop will be great. So we'll share that after this meeting. Alrighty, we're slightly behind, so we'll just kick off. Let's start with a presentation. Nenad, take it away.
All right. Is it okay if I share my screen?
Sure.
Gonna try and do that. All right. So has that come up for you?
Yep.
Okay, perfect. All right, so I think we've gone through introductions already. So thank you so much for the opportunity today to talk to you guys about our project. And Kale and I, both of us would be taking turns to present. And based on all of your introductions, you all certainly appear to be subject matter experts in when it comes to water networks. So just a bit of a disclaimer, Kale and I, we're not that. And if there are any questions specific to the way the network works or specifics of the networks, we'll just have to take those away with us and get back to you. But technology is something that we can both talk to today, I suppose. All right, so with that, a bit of a background on how this collaborative relationship came to be. So I met Kale and his crew at Ozwater conference this year, and after their poster presentation on detecting high-speed pressure transients caught my attention. So that's the top right corner over here. Very interesting. If you get a chance to go through it, please do. I'm sure Kale wouldn't mind circulating that after the presentation. So basically, together with SA Water, they had developed a digital tool to digest pressure sensor data recorded from the network and essentially filter transient events from all the background noise that the sensors would record. And that's pretty significant. And I know this because we've had similar experience with another technology that we've developed, SOTO sensors for leak detections. It's quite challenging to separate out the interesting events from the uninteresting background noise. So that got me really very excited that Kale and his crew already had a prototype solution to do that for pressure transients. So following that, I basically got back to Melbourne and touched base with our network operations people, reliability teams and digital utility teams who sort of agreed that we need to do more in this space. And I think stars almost aligned at that point when Jason Cotton was also interested in pursuing this trial from an IWN perspective. And Kale, I remember Kale did speak about a bit of a discount to the trial, so it was too good to let go of that opportunity, and hence we're here. All right, next slide. So in terms of our problem statement, it's quite simple, really. So we need to monitor pressure transients and link them back to root cause for us to take preventative measures for preventing asset failures. So quite simple, quite straightforward. That's our problem statement. And talking about pressure transients themselves, so pressure transients is not an isolated problem to Southeast Water. It's an industry-wide problem where various activities in the network, such as valve opening and closing, irrigation solenoid or systems turning on and off, fire testing or hydrant usage, they tend to trigger these pressure transients. And in terms of what they actually are, they're really spikes in pressure that basically travel throughout the pipe network, and they last for a fraction of a second. So they're moving at a very rapid rate and velocity. So when these events occur, they tend to accumulate fatigue in the pipe network, which reduces asset life and eventually results in asset failures in the form of things like leaks, cracks, and breaks. So all of these are really consequences of pressure transients, and what that means for a utility like Southeast Water is, our OPEX and CAPEX expenditures automatically go up, life of our assets is reduced, and all of that then has impact on our customer service. We're not able to meet or achieve our desired customer service levels.
So, Ninad, is it okay if I just make a comment?
Yeah,
so,
go for it.
So Ninad's given a very good overview. I think so. We're external to, so Spiral Data is external to the water industry, although the water industry is largely our customer base. And so we do have the perspective of other industries, and what's really obvious to us is that higher speed pressure transients are a largely undetected and unknown problem throughout the water industry. So the water industry over the last few years is getting better at leaks and leak detection, but often further upstream, it's caused by a repetitive higher speed pressure transient that the water industry or the water utility just has no idea about what that root cause is. So it's a really interesting space. The problem statement for Southeast Water is very operational. We've done previous work with SA Water that was very strategic and planning, and they're both equally valid. So SA Water are coming at it from how to avoid CAPEX being brought forward from the accumulated fatigue that Nina had spoken about, and Southeast Water for the moment are focused on how do we minimise operational impacts. Yep, just a couple of extra points in it. I did a very good job though.
Thanks, Gail. Thank you. All right, and yeah, to Gail's point, spot on. These events, in our discussions with our operations and reliability teams, there are suspicions that we have pressure transient events at certain locations within our service region. But as Gail says, the monitoring has been the challenge so far. So we can't say for sure that the asset failures in that region are because of transient events. And the first step to sort of confirm or disprove, so to speak, that hypothesis is actually being able to measure pressure transients, which is what we're doing with this trial. All right, so in terms of the future and vision for the future, we have a vision for something called as a calm network, where there are no pressure transient events. Whatever pressure transients that were existing prior to this state, we would have got to the bottom or the root cause of those events, and would have taken preventative measures thanks to the high-speed sensor, pressure sensor that would be installed throughout the network at strategic locations, and pairing that with a platform such as Spiral Data's platform, which would help pick out those pressure transient readings, help detect those, separate them from the background noise, and that would then in a ideal state, it would help lower our CAPEX and OPEX spend. It will help increase our asset life, help improve our customer service. Coming to the technology, perhaps Gail, maybe if you can provide a bit of a quick technology overview on how the platform and the sensor paired with the platform works, and what sort of data is available to a user.
Yeah, yep, sure. So there's a couple of reasons that this problem hasn't been solved widely across the water industry. And so the first one is the data collection. So as Nat mentioned, higher speed pressure transients move very quickly, typically around 1,000 metres a second. So that means your collection rate at your pressure sensor needs to be very high frequency. So for SA Water, we were operating at 128 hertz. For Southeast Water, we've pulled that down to 100 hertz. And that's important just so that we just don't miss these higher speed pressure sensors. I think it's important to point out Spiral Data is not the sensor company. We're the analytics or big data and ML company. So our future state would be that the sensor companies are really mature in this space and they're able to provide standard integration points for companies like ours to add value. So where our technology picks over, or starts over, is the platform. As Nina mentioned, there's a lot of data. This is a big data set. So 128 times a second, 365 days a year, roughly equals a terabyte per sensor per year. So what we've been able to do, and we've done several engagements with SA Water over the previous 18 months, is we've been able to develop a series of algorithms that essentially removes the noise. And so what it does is it picks out the actual pressure transients themselves. And so it does this to a really high reliability. So we're around the 97% accuracy score at the moment. And that's validated against someone who has postgraduate research expertise in pressure transients, and it's comparing their abilities versus the algorithm's abilities. So it's got really good confidence in being able to snip out the actual algorithm, the pressure transient event. But then the problem with that is that then you end up with thousands of pressure transients, and it's not humanly possible to actually go through each of these, and it's just a huge body of work. So then we have another algorithm that then will group together, and you can actually see down the bottom right, this is a grouping of the subsequent algorithm that is really looking for similarities in how the behavioural characteristics, that pressure transient, and this is all done automatically. And so it's a little bit difficult, but at a high level, on the left, we have the pressure transients as a big data set. So you can see there's some really big pressure transients that is denoted by the size of some of those bubbles. The colour is the sensor. So you can see that there's certain patterns around blue and red at a really high level. You're able to zoom in, zoom out, etc. Then on the right, you've got those grouped together as event groups. And so what this does is it helps the utility then start to really narrow the needle in the haystack. So really trying to reduce the haystack to try to figure out what is ultimately the root cause. Down the bottom, you see a little column chart as well. And this gives you a time reference. So it starts to tell you which days a week, which time of day that this group is occurring. In some cases, it'll be random. In other cases, it'll be really specific. So as an example, for SA Water, they were able to identify several root causes just from desktop study around fire testing that occurred at the same day of week, same time of day, consistently. Also around automatic valve closures as well. I think I'd mentioned irrigation systems, and then pump stations where two pumps were interacting with each other and creating pressure transients and causing all sorts of havoc in the system. The other, I guess, indirect benefit that we've come across is the higher fidelity baseline measure that could be an input into subsequent hydraulic models as well. So these screenshots of the web application down the bottom that the end user, the subject matter expert, can use to start to interrogate the pressure transients. And the obvious question to ask for all utilities, is it us, is the first question. We find that it's often assumed it's the customer, and quite regularly it's your own assets that are causing it, and sometimes it is the customer as well. So hopefully that's a high level overview. Do you want me to keep going, Hinard?
Yeah, do that. It's fine.
Yep.
For the next 2 slides, if you can.
Yeah. So while there are a lot of transferability from one utility to another, each utility does have its own unique network, its own idiosyncrasies with how it's set up. So we we're nearly complete a co-design phase with South East Water. We ran a workshop over in Frankston, and ultimately this is the output of getting a multidisciplinary team into the same room. And we can see that we were able to land on some sites of real interest. Those are in the middle. So some high density, high-rise buildings, industrial areas in Dandenong, and a particular pump that is suspected of causing a range of pressure transient issues. The business case, it was really interesting how the co-design, the ROI that Ninad mentioned before was really well confirmed, which gives a lot of people assurance that this is a problem we're solving. And on the right, we've got a whole bunch of pain points that came out of that co-design workshop as well. The list is long. I think the important question, though, is can we find it? And the goal for this particular trial is to find it using desktop study. So we're going to limit it, not do any field investigations at this stage of a POC trial. And based on what we've seen in SA Water, we're confident we should be able to find at least one pressure transient. And then South East Water can make subsequent steps to mitigate. Yep. And so in terms of the future state, the idea is to switch around the ROI on the left there. For the sites, we're going to focus in on this pump at Frankston, and hopefully be able to qualify or quantify the pressure, a proxy for fatigue from the pressure transients. Dandenong, we're going to hopefully put some pressure sensors right next to a suspected problem customer and confirm that it is coming from the customer. And for the high-rise or high-density area, measure the direction, at least to try to understand the direction for future functionality. I'm not going to go into detail, at a really high level. I think that's the key points.
All right, thanks, Kale. All right, so in terms of the trial plan funding and resourcing that's available for this project, it's planned to be a 4-month project with a 3-month trial in there from August to November, and we've also got an option for extension of that trial. Once those sensors are installed, at the end of the trial period, we might reassess our business needs, reassess our funding availability, and if everything checks out, then we might actually extend the trial period. Something we haven't decided yet, but that's still on the table. In terms of the total cost, so this phase 1, what we're calling it, that's going to cost us around 125 grants, of which AWS is contributing 37 grants. And because there are so many acronyms in water industry, I like to confirm AWS is Amazon Web Services and nothing else that someone's come up with in water industry. So IWN is also contributing around 30 grants. Spiral Data has kindly offered a discount of 15 grants, and Southeast Water will be contributing around 43 grants for the trial. In terms of resourcing, Southeast Water will be responsible for project management. We'll also be providing some of the subject matter expertise for this trial, and we will be looking after the sensor installs, whereas Spiral Data will be responsible for managing the trial, as well as the project from Spiral's perspective. They'll be managing the Transit Detect platform. So this platform that Kale was talking about earlier, it would be hosted completely on their servers, and we'll just get a benefit of or access to the front-end user interface of that platform. And of course the data science sprints. So Spiral's got data scientists that work for them, and they'll be getting a couple of senior data scientists to digest the data that would be generated from this trial. And last but not least, IWN will be providing a bit of a governance structure, as well as helping with reporting in the form of reports, as well as industry communications that would be released through the IWN network. Yeah, that's really all we had, Christina. Thank you. Happy to take questions.
Thank you, guys. That was really interesting. Can't wait to see what we find. Anyone has any questions?
Thank you so much for the presentation. It's very exciting to see this happening. I've been thinking about that in the past and couldn't find the momentum. Now it's good that we have someone pioneering on that. That's really beneficial to everyone. My question is that who will be defining the strategy for deployment on the sensors? Is it like a collaborative work between different entities, and what's the criteria for identifying the right location for the sensors?
Yeah, that's a good question, and Christina, jump in if you know anything further on this. But look, I think it will be done in stages. So first, we need to prove that this technology works, which this trial would help us with, and then following that. It would be, I think, we'll need to work out how widespread this problem is likely to be, and that would be done with a range of people in the business. So I'm thinking about our network operations teams, our reliability teams, hydraulic planning teams, as well as digital utility teams. I do know for the sewer side of things, we've got working groups. That these different departments have representatives from, and these working groups, they basically are responsible for deciding upon the appropriate deployment strategies. Because from a sewer perspective, level monitoring is just one thing, but there are various other things that you can do. And then from a deployment point of view, you've got to make sure that all these technologies coexist with one another, and that we're not effectively doubling up. So I think if it already doesn't exist, that sort of working group for pipeline, it would be put in place for Southeast Water to decide on the deployment plan.
So, and maybe just to add a little bit of context to SA Water, so they're currently in their second phase of procurement for their higher speed pressure sensors. So I mentioned before, we're not the sensor company. And something that might be helpful is their thinking around the fleet. And so the way their thinking is evolving as we understand the problem better, the layers of the onion are being peeled back on higher speed pressure transients. But their thinking at the moment is that they have 80% fixed sensors. So the sensors are fixed in key areas of the network, and they call those their sentinels. They don't move, and they have 20% scouts. And so these are sensors that have a problem area. They have the agility to move the sensors to where the problem is, and then they can move those as required. So I hope that gives you a little bit of context about how to maybe think about that future state.
Yeah, I also was thinking that potentially there's there's opportunity to get university involved in terms of the identifying the best location to put those sensors that pick the best location of the potential high transients based on the customers. Usually it's coming from big customers like that have a big water usage. Normally we don't get that from small customers, so we know where the sources could have been. Then they may come up with a modeling solution saying that, hey, this is where it's best to put those.
I maybe Just to put some constructive thinking out there, I can see a future state if the sensor companies really mature their technology and the price of higher speed pressure sensors comes down and it really just becomes a commodity. I can see utilities covering the majority of their networks, particularly around their own assets as a start point. And then in a future state where there's a customer connection, having a higher speed pressure sensor in that customer connection as well. So I think I'm talking decades, but it might be quicker. I'd like to be proven wrong. But the future state would be, every customer that causes you issues, and every asset that causes you issues as well. And as the cost drives down per unit, it should become possible.
Yeah, but I think you've raised a good point, and your suggestion's quite right, because this approach of getting PhD university PhD students involved, and we've taken that for our vibration sensor deployment, because effectively it's a optimization problem. In a single block, how many sensors do you really need? Do you need one at the front of every house, or do you just need one or two covering a bunch of houses? So we've taken that approach with our SOTO vibration sensors. Perhaps it could be the same for this one as well. Let's see how it pans out.
No worries. Thank you.
Thank you. Anyone else have any questions? Okay, thank you guys. That was really interesting, and yeah, come back anytime to our working group to give us an update if you like. Open invitation.
Sure.
Hi,
No
Jason.
worries. No, thank you.
Hi. Yeah, I've been lurking in the background. Sorry about that. I had an urgent matter to attend to at 10 o'clock. Yeah, that was great, guys. I caught from about 10:20 onwards. So, yeah, really great explanation. Yeah, tremendous stuff. Thank you. So, yeah, looking forward to the next presentation to share some results. Be cool.
Thanks a lot, guys.
Thanks, Jason.
All right, no worries. You guys have a great day. I'll be in touch shortly. All right.
Thanks.
Cheers.
Thank
See you.
you.
Bye.
Lisa, if we could just have the agenda back on the screen. Okay.
I'm leaving my camera off, Christina, so
Yes,
hopefully the signal's a bit better.
That's completely fine. And yep, let's do a quick overview of the current projects that we're looking at. So we already touched on SmartCrete research project. That's a collaboration between La Trobe University and Intelligent Water Networks, where the research is I guess, and we just got a PhD student. When I say we, I mean La Trobe University got a PhD student finally on this to start identifying. So first with the objectives, with the industry workshop, which I mentioned already. So we'll share those details with you. And it's just as I said, more of a review stage at this point, and we'll be providing updates as we go through that process. FibreSense, if it's okay with you, Elisa, could you give just a quick overview on FibreSense?
Yeah, of course. So it is still tracking ahead. FibreSense has been engaged and is doing some work with Greater Western Water at the moment. We are hopefully going out to site on Thursday night to run some simulated leaks from the network we are currently reviewing with this technology. And if that trial does go ahead, if the actual simulation occurs on Thursday night, we can give everyone an update. But at this point in time, the technology seems to be tracking, gathering the data well, but until we actually can simulate some leaks, we can't verify that at this point. So fingers crossed we get out on site on Thursday night.
Yep. And just, I guess, for those that are not familiar with this project, so that's basically the idea is to use the fiber network as a sensor to listen for leaks, and you could do other things, or you could listen for any ground disturbance or any dull, in anyone digging in the vicinity of your assets that potentially shouldn't be there. But I think the focus right now is just on leaks. Is that correct, Elisa?
No, we can look. We will be looking for both. I think that
So ground
the issue,
vibrations as well. Okay.
yeah, the issue with this particular trial is that we are testing it in the city. So we may have some other disturbances with regards to, you know, whether it's trams or heavy vehicles, but that's part of this test, is to see how sensitive it is and whether or not we can eliminate those
The noise.
particular
Yep.
vibrations that are coming through. Yeah.
Great. Thank you. So we'll hopefully provide another update on our next working group meeting. Vapor. So we had a presentation from them last. Was it last? Oh no, it was a webinar, wasn't it? Where we had
Yes.
a presentation.
Yeah.
So so those maybe that weren't able to attend that webinar, we can potentially, or well, everyone would have been sent an email with a recording. Is that correct, Lisa? So they can have a look.
Yes. Yeah, I've sent that out, but I'll add into that for everyone.
Great. And is there, so the update is that finished now, the trial, or is?
Yes.
Yes, it's finished.
Well, actually, no. Yes, yes and no. We are just finalising. We've finalised the trial that's happened at Taswaters, so we have a report for that one, and we are kicking off another trial at Goulburn Valley Water as we speak. And so once we get that, we can collate all of that information and send that out as a report as well. And I think the other thing to note with Vapor is that they are also being added to the e-services register. So being able to purchase this as a product will be made a lot easier for the water industry as well.
Right. So once again, Vapor. So the technology is for automated CCTV pipeline detection. An artificial machine learning technology to identify defects and automate the CCTV reviews. Hydro, I might get you to talk to that one, Jason, if that's okay. So it's a self-powering.
I don't know whether Jason's still on the call.
Is he gone? Okay.
I'm not sure. Yeah. So that's it's still in train, Christina. I don't think anything's been defined with that as far as it running as a trial. Having said that, I know that Grant at Greater Western Water has made provision for it at the training main at Melton. So we're just working through some of the technicalities of actually bringing this tech over and being able to trial it.
So yeah, so what's unique about it? It's self-powering flow meter, so we don't need external power to it. So of course it will require a certain type of velocity to do so, and currently it's only specific to certain type of sizing of pipelines. But once we have more information, and once it kicks off, the trial kicks off, we'll share more information on it. And we already talked about Smartcrete. So that's all for the current projects. May I open up the floor to general business if anyone has any. And that's fine if no one does, but great. So I guess that's a wrap for today. Our next meeting will be, oh wow, it's October. It'll be October already. So 17th of October at 10 a.m. Time flies. Thank you all for attending.
Christina, can I just ask the group if there's anything they would like us to focus on, or whether or not they would want to deep dive into any of these current projects? And the other thing that I'm working through at the moment is doing a bit of a rationalisation and a recalibration of all of the trials that we've done right across the IWN program, but there are a large number of them sitting in the pipeline in intelligence space. So once that work has been done, I can certainly share that with the broader IWN community. But if there's anything that you would like us to focus on for the next meeting in October, you don't have to answer it today, but please send us through some ideas, and we can certainly factor that into our agendas moving forward.
Great.
Thanks.
Thank you. Thanks, everyone.